Today, we will be talking a little bit about trusting the data, sensor validation, as well as how that plays a role in design and manufacturing when it comes to wind tunnels, wind tunnel testing, and CFD, or computational fluid dynamics.
Go slow!
Action! Action!
I think one of the things I would like to pull back a little bit on is this is not intended to replace wind tunnels. If you're a prototype developer, really what's happened is you've done a CFD development, you've done development towards creating a small version of that, you've taken that to wind tunnel, you've scaled it up, made a full-size version, and then you've released your product. You have the capability now between that. You can take your existing product, you can actually a real-world test with our type of technology, and then you can bring that information back into the CFD. So the reality is we're adding another layer of increased, I guess, quality and development in aerodynamic performance.
Augmenting a little the design.
Yeah, and you can get a chart of this actually on our website, which we'll have linked below, but it'll explain the engineering evolution and where this actually brings more value to you as an engineer to develop an even better product.
Right.
So that's one thing I definitely want to point out right off the hop.
So, and what I think I would like to speak to a little bit is we have these 3 steps in the process in some design when it comes to aerodynamics and structural integrity of, say, a frame or a wheel, and responsiveness, weight, all of these things come into play. You have your CFD analysis, which may include a structural solver as well. So your CFD is solving the fluid flow around the body and giving you drag information. There's significant limitations in CFD solvers. CFD solvers, you need to choose, am I going to model turbulence? How am I going to model the ground? Is the ground going to be a rough ground?
And there's even limitations on that where you can't do spokes and so forth. So your resolution and your screening is very limited.
Of course. If you're making dimples, for example, that are similar to the size of dimples that would appear in, say, a golf ball, but equivalent dimples in a wheel, really tough to computationally model. The computations are getting better with increases in computing technology, but it's still a very, very strong limitation.
And
rotating, costly. Some people may claim that they can do rotating wheels. And a rotating wheel system, you either have to have an overset mesh on your CFD solver, and there are specific equations that handle the communication between the fluid and the solid that's rotating around. Really challenging to do. It's not completely fleshed out.
But it's still valuable when you're developing your first iteration of your prototype, which then you take that and you create a 3D model, maybe a miniature, and then you take it on into the wind tunnel.
So now we're in the wind tunnel. Oh boy. This is where there's a lot of challenges. From wind tunnel to wind tunnel, we've talked about in previous videos, we'll get differences in results. But not only that, your wind tunnel itself is not the same as CFD. The boundary conditions on your CFD model are not the same as a wind tunnel. You can't compare the two directly in the same way unless you have an extremely careful study that's been carried out, which they're very rare to find, extremely rare to find. Oftentimes in a wind tunnel, like a component wind tunnel, what you end up doing is you just have that one piece of equipment in the tunnel. So it might be just the wheel.
Yep.
And I'm just testing the wheel. So you're never really getting the holistic aerodynamics integrated with the bike frame necessarily.
Or even when they bring in an athlete, so they put the athlete on the bike, he can't actually perform to his optimal race pace because he throws off the scaling system and so forth. So he often simulates the decycling.
So a typical way in a wind tunnel where you're measuring drag is underneath the tunnel there is a force plate. And that force plate has to mount to the bicycle. So for it to properly mount to the bicycle, usually those are some obstructions, like an aluminum mount or something like that. Try to minimize them as much as you can. Try to zero it out as best you can. Rider gets on the bike. He's rocking all over the place, trying to get comfortable inside a wind tunnel for the first time in his life, hopefully not the first time he's experienced. Even then, you're going to have challenges around teasing out from the noise that's generated by the rider, what your true drag and lift and side force values were dynamically. And then And then you come down to the point of, was that rider even comfortable? Can he sustain that position when he goes to the road? Or did we just put him in a position in a wind tunnel that is really just unrealistic?
Yeah, but keep in mind CFD, from the original concept to the 3D printing to the tunnel, it has value.
Yes, absolutely.
You can deal with yaws, you have a controlled lab test, so there's important values with that. But I think also, as we can kind of continue to that, then traditionally they would say, okay, we're good to go. Now let's heavily invest in the molds or whatever it is to develop a product. And really what happens is AeroLab's technology now adds another layer of, call it less guesswork and comfort, because they can now take and add another layer before they spend the huge capital investment of that new product on how it responds into the real world.
Yes. Yeah. Yeah. And from a manufacturing standpoint, I agree completely that that's sort of part of the design process where you can iterate quickly and field test. Whereas field testing is usually more reserved towards the end of the design process. Now it can become more integrated, or at least I see the potential in that. For riders, when we're talking about validation from a coach or from an athlete's perspective, say you get yourself scanned and you decide to do a CFD analysis of a scan of the rider. There's some systems out there that do that. You can't compare that directly with the results you get on the road. There's major differences, like I just discussed with CFD. You can't compare your results you get in a wind tunnel to the road. It is a different environment, different boundary conditions. A wind tunnel's boundary conditions, the floor of the tunnel, it's not moving. The ground below your feet is moving when you're in and pedaling down the road.
And to that point, now we're dealing with turbulent airflow in the real world, which we've experienced, whether it's rough road, all of a sudden the rider's on, which changes that.
The gradient.
Yeah, and even just certain grass and so forth, and all of a sudden that turbulent airflow, you go past a cluster of trees. So
yes.
Definitely it's a different world. It's a real world. It's a different environment. There you go. So
how? I mean, I've talked about this. I don't want to end on a negative, so I do want to make sure that I, end on something that's a little bit more positive to take home from this. And it's not that all of these technologies can never be compared ever. It means that in an absolute sense, it's difficult to compare them. In a relative sense, you can. So what do I mean by that? What I mean is if you decide to change out a helmet, the change in drag you see when you change out that helmet should be similar when you go from the wind tunnel, from CFD to the road, if they're all done properly. If the testing was done properly and regimented, if the CFD was set up properly with adequate modeling of, say, turbulence and things like that, and adequate mesh resolution, and if the field test was conducted well, and if your wind tunnel test was carried out carefully.
This is a next evolution to enhance a technology that's been around for a long time. CFD development, it's very costly, but it's good for a certain stage. Wind tunnel is also good stage. This brings in another factor to just reduce really energy loss, wasted energy.
Yes.
At the end of the day.
Yep.
So that's really our end of takeaway. So hopefully you found that interesting. If you want to learn more, definitely comment below. If you want us to do other videos and so forth, definitely like us on YouTube here, follow us, and we appreciate it. And we look forward to actually seeing you at the symposium.
Yes.
That would be awesome. Take care. Thanks again.